Hello class, welcome to Unit 2.2a, Solving Equations, Word Problems. When we work with word problems, a few things that we're going to want to take note of is 1, defining your variable. That way we know what we're talking about as we set up our equation. Which brings us to a second thing that's going to be important is making sure we write out a nice equation. And then it's going to be, once we get that, it's just going to show your work and make sure you're answering the correct thing based off the question. Now, also while we're looking at these word problems, it usually comes from two types. It's either going to come from the words, or they could take the form of a rate problem, which usually is set up with your total would equal the rate times time plus your initial. So we'll take a look at a few examples of those. Okay, first example. From the first quiz to the second quiz, a score dropped 8 points. The score on the second quiz was 39. What was the first quiz score? Let F represent the first quiz score. So right here, this one was nice enough to tell us how to define our variable. So we're going to start with just saying that F is the first quiz score. Alright. And then what we need to look at is what else is this problem telling us? This is just telling us that the score dropped 8 points and the second quiz was a 39. So what this is telling us is if we have that first quiz and it dropped, which is just going to tell us -8, and it equals our second 39, there's our equation. Well, from here, add 8, F equals 47. Well, a lot of times once we get this answer, the word problem is, well, what does that 47 really mean? So restate our answer, and 47 was the first score. So we're basically saying first score of 47. And we're all good to go. Check your work and make sure everything looks good. Okay, looking at example B, 10 is 5 less than 3 times a number. So what are we missing out on? I'm just going to call this n, and that's going to equal a number. Nothing fancy with this one. And this one's pretty straightforward. Let's break it down. 10 is, well, that's just another way of saying equals. And now we got to look at 5 less than 3 times a number. Well, that means we are doing 3 times a number, and then we are taking 5 less than it. Well, right there we go. Let's solve it up. Add 5, that's 15, equals 3n. And do our inverse operations. So 5 is equal to n. Again, kind of check your work out here. This one here to state our answer is just a number. So we don't have anything more to add to that. So let's take a look at another one. Okay, let's look at a third example. Producing a musical cost $88,000 plus $5,900 per performance. One sold out performance earns $7,500 in revenue. If every performance sells out, how many performances are needed to break out? Well, let's start looking through a few of our information. We have costs of $88,000 plus an additional $5,900 per performance. We also have it earns $75 per performance. So this is going to set us up to be a rate problem. So when we start looking at these, actually going to have 2 rates. But let's talk about what are we missing here. The part we don't have is this per performance. So that's where we can define our variable as P, and we can just call that a performance. Now, when we look at our total, This is another one where it's talking about break even. So break even just means when is this thing going to get back to 0? Okay, so our rate times time, this is indicated, well, in this case, two different problems. Not only is it going to be the 5,900 per performance, that's a cost, it's also going to be earning 7,500 per performance. So when you go to set this up, the first thing I would look at is say, we got 7,500, that's coming in. Revenue is positive. If we're looking at the 5,900 cost, that is minus 5,900. And before we even get started, it had that cost of 88,000. So this is going to be minus 88. Oh, let's see if we can squeeze that in there. And that's going to get us set up. So we used some of our rates. Okay, so you saw the positive rate and revenue, negative root. And we had that initial in the 88,000. Well, let's solve. This one's going to allow us to work through this and say, well, what's 75 minus 59? We got 1,600. Combine our like terms. And then we have that minus 88,000. There you go. Hopefully you can see that a little bit better now. Well, now we get to solve. Don't be scared of that 0. We're still going to solve by adding 88,000 to both sides. And then what we can do, 88,000, need another 0. And then we can divide by 1,600. So what that looks like is we're going to have 55 performances before we can break even. Oop, looking pretty bad. Performance. Oop. Hopefully you see that. That should say 55 performances. Remember, always returning our answer back to the question that it was originally asking for. Okay, at this point, use what we just did to practice 2.2a. Good luck.